Hello, Algebra 2. So we are going to start in chapter 1 today. 1 is linear equations. At some point, we'll have like a uniform chapter, but in the beginning, we kind of go all over the place. So 1 is linear equations. Okay, so we're going to start off with something you know how to do. And for all of these equations, all we're going to be doing is solving for x. So solve the equation for x. Okay, so like I said, this first problem, I'm not going to do much. I'm going to just let you guys kind of remember how to do algebra. So your problem is going to be 7 minus the quantity of 2x minus 1 equals 10. Okay, so I want you guys to pause me here. I want you guys to try that one on your own and then come back and check your work. So pause, come back, check your work. Okay, you should be coming back to check your work. I'm going to do one of these steps just to make sure we understand this, and then the rest I'm going to just do quickly. So your first step here, and the most important thing, and the area where most people make a mistake, is forgetting to distribute this negative to both the 2x and to the minus 1. So this becomes 7 minus 2x plus 1 equals 10. So from there, we just combine like terms, start getting that variable by itself. So I just subtracted 8 from both sides, and now I'm going to get x by itself by dividing both sides by -2. And I get x is equal to -1. Remember, you can always check your work by plugging it back in. If I plug this back in, 2 times -1 is -2. -2 minus 3 is, or I said it out loud, -2 minus 1 is -3. 7 minus -3, a negative and a negative make a positive. And so that gets me 7 plus 3, which is 10. So it works out. So you can always check your work with these by plugging it back into the equation. Okay, let's try another. Let's throw in some fractions. Now, however, there's a lot of ways that you guys can deal with this, and it really is up to your comfortableness with fractions. So this example is going to be 1/2 minus 1/3 x is equal to 4/3. Now, you can do this exactly like we did over here. You can subtract the 1/2, multiply both sides by the reciprocal, get x by itself, totally fine. Another way that you guys can do this, if you are not comfortable with fractions and you want to get rid of the fractions, is look at the denominators. So if I look at the denominators between 2, 3, and 3, so all of my denominators, 2, 3, and 3, I think about what would be my common denominator there if I were trying to get a common denominator, which I'm not, but if I were. So between 2, 3, and 3, my common denominator would be 6. So what we're going to do is we're going to multiply the entire thing by 6/1. So let's make a note of why I picked 6. So 6, again, we're going to multiply the entire equation by the least common multiple. The least common multiple is always the same as our common denominator of all the numbers in the denominator. In the denominator. Which between 2, 3, and 3 was 6. Okay, so what happens, I'm going to do one step extra than I normally would do. And so what happens, 6 times 1 is 6, and then 1 times 2 is 2. And then this becomes 6 over 3x is equal to 24 over 3. Now, you're probably thinking, well, that didn't get rid of the fractions, but it does. Because 6 divided by 2 is 3. 6 divided by 3 is 2x. And 24 divided by 3 is 8. Now, that problem that was fractions and was a little ugly is now basically something over here that you guys can like easily solve. Subtract the 3, divide by -2, and I get x equals -5/2. Again, we can plug that in, always check our work. But this is just one way of getting rid of the fraction to make it easier if you are more comfortable with that. You have to multiply the entire equation by whatever number it is to get rid of the fraction. So again, I do like one extra step than I normally would do. Typically, I do this in my head, and I just think, okay, 6 over 2 is 3. 6 over 3 is 2. 6 divided by 3 is 2. 2 times 4 is 8. So that's typically like how I just do it in my head. But if you want to write it out, which I'll probably write it out a few more times so you guys can see it, then that's great too. Okay, let's try another example. If I have 1/3 x equals 2 minus 2/3 x. Now, again, you guys can solve this, just like add the 2/3, like go through that process, keep it as fractions, but I'm gonna keep going with getting rid of the fraction altogether. So I look at my denominators. My denominators are 3, 1, and 3. And so the lowest common multiple between 3, 1, and 3 is 3. So I'm gonna multiply my entire equation by 3 over 1. Again, I'm going to show you guys that extra step. So 3 times 1/3 is 3 over 3x equals 6 minus 6 over 3x. Okay, well 3 over 3 is 1x. 6 over 3 is 2x. And then I can solve. So add 2x to both sides. I get 3x equals 6. Divide both sides by 3, I get x equals 2. And that is your final answer. Okay, we're going to keep going. Number 4. Okay, so if we have 3 over x minus 1 over 3 equals 1 over 6. Okay, so again, look at my denominators. Between x, 3, and x, 3, and 6, what would be my lowest common multiple? And if you're thinking 6x, you would be correct. So I'm going to multiply the entire thing by 6x over 1. Okay, so what I want you guys to do is I want you guys to pause me here. I want you guys to try this one on your own. I'm going to write out that extra step. If you don't need to, if you can go straight from here to here or here to here, great. If you need to write out that extra step, you need to do that. Okay, so I multiplied 6x and I got 18x over x minus 6x over 3 equals 6x over 6. I'm going to simplify. The x and the x cancel to get me 18. Minus 6 over 3, which is 2x, equals 6x over 6, which is 1x. Okay, now I want you guys to solve the rest of that problem on your own. Come back, check your work. Okay, so you should have gotten x equals 6. Now there is one new thing with this problem. Now that one new thing with this problem is the fact that we have a variable in the denominator. When there is a variable in the denominator, we need to check the solution. So let's write that down to remember. So when there is a variable, in the denominator. You need to check your solution. So the reason we have to check when there's a variable in the denominator is to make sure that this solution doesn't make the denominator 0. So all we have to do is very easy, just plug it back in. Most of you guys will be able to do this in your head. But 3 over 6 minus 1/3 equals 1 over 6. I just plugged in 6 for x. So that's and honestly, that's really all I have to do to check. I could keep going to make sure I did the math correctly, but in terms of checking to make sure that the solution doesn't make my denominator 0, we're good here because I plugged it in for the denominator there, and it didn't make my denominator equal to 0. So all you're doing is you check to make sure the solution, check to make sure the solution does not make the denominator equal 0. Which it doesn't, so 6 is my solution. Okay, let's try another one. Okay. So number 5 is going to be 4 over x minus 5 equals 5 over 2x. So first thing I'd want you guys to think about is what would you want to multiply the entire equation by to get rid of the fraction? So first, think about that on your own. Come back, see if you got the right thing, and then we'll keep going. Okay, so I look at my denominators. Between x1 and 2x, the lowest common denominator there, the lowest common multiple, would be 2x over 1. Okay, so I want you guys to multiply that through and then come back, solve it, go through the entire solving process, and come back and check your work. Okay, so I just started by multiplying the 2x through to get 8x over x minus 10x over 1 equals 10x over 2x, which again, you don't need to do this extra step. I'm going to keep going. So when I simplified, I got 8 minus 10x equals 5. The x's cancel, nothing in the denominator. 10 and 2 simplify, and the x's cancel. And my final answer is x is equal to 3 over 10. Remember, I still need to double check to make sure that that does not make my denominator 0. I can just do it mentally. Like I can just plug it in. 3 over 10 doesn't make my denominator 0. 2 times 3 over 10 doesn't make my denominator 0. So we're good. But you still need to check it. So just like we did here, we still need to kind of mental math check that too. Okay, so let's continue on with another problem. We're going to do 6. So we have x plus 2 times x plus 3 equals x plus 3 squared. Okay, so from there, what you guys are going to do, think about it. What would you do first here if you were trying to solve this problem? And if you're thinking multiply it out, you would be correct. So we would multiply this out. So I'm just going to multiply x times x squared, x times 3, 3x, plus 2x, plus 6. And then remember, x plus 3 squared, that doesn't mean we can distribute. What this means, remember, is x plus 3 times x plus 3. This is saying x plus 3 times x plus 3. So we're going to multiply that out. So that gets me x squared plus 3x, so 6x plus 9. And now from there, we can solve that. You can combine like terms. So x squared plus 5x plus 6. Now, first thing I would do is I would move my x squareds to one side of the equation. Now, what's going to happen if I move my x squared from here to over here, it's going to cancel. X squared minus x squared is 0, and x squared minus x squared is 0. It goes away completely. So I'm just left with 5x plus 6 equals 6x plus 9. Oops, there's my head. So from there, I want you guys to continue solving that problem and get x. So continue to solve that one and get x on your own. So I just moved the 6x over. I got negative x plus 6 equals 9. I'm going to keep going. And I get negative x equals 3. I'm going to keep going, divide both sides by negative 1, and I got x equals negative 3. Do I have to check that one? Nope, because there isn't a variable like these in the denominator. So I'm good on that one. I don't have to continue, and I don't have to check that one. Okay, let's continue on to a new problem. So let's go on to 7, where we have, oops, let me move over. There we go. 8x plus 5 over 10x minus 7 equals 4x minus 3 over 5x plus 7. Okay, so we have a variable in the denominator. So right off the bat, we know we have to check this one. But we have an equation. We have two proportions, or we have two fractions that equal to each other, which is a proportion. So to solve that, what we can do is we can cross multiply. So what I'm going to do is I am going to cross multiply 8x plus 5 with 5x plus 7. And then I'm going to set it equal to 4x minus 3 times 10x minus 7. Okay, so now all I have to do is just multiply that out. So 8x times 5x is 40x squared. 8x times 7 is 56x. 5 times 5x is 25x. 5 times 7 is 35 equals 4x times 10x, which is 40x squared. 4x times negative 7 is negative 28x. Negative 3 times 10 is negative 30x. And then plus 21. So I'm just going to combine like terms on both the left and the right side. So 56 plus 25, those can be combined. And then over here, negative 28x and negative 30x can be combined. So I'm left with 40x squared. 56 plus 25 gets me 81. And then bring the 35 down. Equals 40x squared. Negative 28 minus 30 gets me negative 58x. Plus 21. From there, it's kind of similar to what we had on number 6. We want to get the x squareds on the same side, but what ends up happening when I subtract 40x squared is they both cancel out. 40x squared minus 40x squared is canceled. 40x squared minus 40x squared cancels. And I'm left with 81x plus 35 equals negative 58x plus 21. And then I can start to solve. So I'd add the 58 to both sides. 58 plus 81 gets me 139x. Subtract 35 from both sides, and I get negative 14. And then divide both sides by 139. And that is it. I know that's a super ugly answer. That's okay. You do need to double check. So does that make my denominator equal to 0? easy way to do that in your calculator, if you plug that in, if you get negative 114 divided by 139, and you go down here and store it as x, I can simply plug that in. I can go 10x minus 7, and what it's doing is doing 10 times that whole thing, minus 7, doesn't get me 0. And then 5x plus 7, again, it's multiplying 5 times that whole thing, and it doesn't get me 0. If instead you want to do 10 times negative 14 divided by 139, minus 7 gets the same thing. And then 5 times negative 14 divided by 139 plus 7 gets the same thing. So just like a trick for your calculator. But so this is good because it does not make my denominator equal 0. But let's write that so we remember that we did check it. So does not make the denominator equal 0. Okay, so we're going to move on. We are going to do one more example of these, but I'm going to do that with you guys as a class. So if I don't remember, remind me to do that. Like this is like an indicator of who has watched the movie or the video, who has watched the notes video, who reminds me to do this extra problem. Okay, so we are going to go on to some word problems. So I am going to pause. I'm going to write it out so then you guys can pause. So you don't have to we don't have to sit here in awkward silence as I write out these problems. So I'm going to write it out and then I'm going to let it go and then you guys can pause it yourself. Okay, so the question is, John worked 55 hours this week. Any hours he works over 40 hours is considered overtime and he will earn time and a half. If John made $718.75, how much is his hourly wage? If you need to pause me to write this down in your notes, pause me now because I'm going to continue solving this problem. Okay, so let's kind of start with how we solve word problems. So to solve a word problem, the first thing I do is look to see what is it asking me to find. And it's asking me to find his hourly wage. So how much is his hourly wage? And typically with that information, I use that to define my variable because that's what it's asking us to find. That's the unknown. So I'm going to set X. You could set H. You could do whatever, W. X is going to be equal to the hourly wage. From there, I just pull out important information. It says John worked 55 hours this week. So that's his total amount of hours. Any hours he works over 40 hours is considered overtime and he will earn time and a half. If John made, that's his total amount of payment. So from there, this is kind of tricky. So we know he's getting paid 2 different essentially wages, right? If you're getting paid $10 an hour and you're getting paid time and a half when you're working overtime, that means you're getting paid that $10 plus an extra half of that $10. So really your hourly wage when you're getting paid overtime is $15. So we take that into consideration. So he's working 55 hours, but 40 of those hours are normal. So, right, 40 of those hours are normal. And then how much did he work overtime? Well, he worked 15 hours overtime. So 40 hours were normal. 15 hours is his overtime. So all we do to set this up is he gets 40 times his normal hourly wage. So that's normal. So that's going to be the first part of the equation. 40 times the normal hourly wage. But then he gets paid for 15 hours. He gets paid his normal hourly wage time and a half. So that's multiplying something, whatever the wage is, by 1.5. If we go back to what I was saying with the 10 and the 15, 10 times 1.5 is 15. So all we do is we do 1.5x to get his total paycheck, which was $718.75. So this is the normal time. And then the 15 times the 1.5x is the overtime to get the total amount of paycheck. And then we just multiply. So 40x stays the same. 15 times 1.5 is 22.5x. So another way of thinking about it, instead of getting paid for 15 hours, he's getting paid for 22.5 hours. It's the same kind of mentality. Either you're thinking he's getting paid for more hours at the same rate, or he's getting paid a higher rate for whatever hours he worked overtime. Okay, so then we combine our like terms. So 40 plus 22.5 is 62.5. X equals 718.75. Divide both sides by 62.5, and I get X is equal to 1150. Now, our question is a word problem, so our answer needs to be in words. So if X is 1150 is his hourly wage, so that means he gets paid $11.50 per hour. And that is number 8. Okay, let's do one more word problem. I'm going to write it out. I'm going to pause again and write it, and then again, do the same thing. You pause what you need to do, and then we'll go through the problem. Okay, so Emma has a total of $34,800 to invest in bonds and CDs. If she invests twice as much money in bonds as CDs, how much money does she invest in CDs? How much in bonds? This is really a throwback to Algebra 1. I could put this in an Algebra 1 class, and this is something that you guys would have been able to do in Algebra 1 also. We're going to solve this a little bit different than the book does. The book solves it as a linear problem. I solve it as a system of equations. I think it's more straightforward that way. But you can look in the textbook, see how they solve it, see if you're more comfortable with that. First thing, every single time I look to see what it's asking me to find. It's asking me to find how much money does she invest in CDs and how much in bonds. So there are 2 questions here. So that means like there are 2 unknowns. So that means there are 2 variables here. X is equal to the dollar amount. I'm just going to put the dollar amount in CDs. And then I'm going to put Y is the dollar amount in bonds. If you put like, C and B, whatever you want to use, it doesn't matter. The variable is not important as long as you know what each variable represents. So first thing, so we have identified our variables, then we look at what's important. Emma has a total. The total amount is super important. And then the fact that she wants to invest twice as much money in bonds as CDs. So let's first, if we have 2 variables, that means we're going to have 2 equations. So we're going to write out 2 equations. First, we're going to make an equation with a total of $34,800. So that's the total amount of money she has to spend. And so it's really a basic equation there. It's the amount of money that she's putting into the CDs plus the amount of money that she's putting into bonds is equal to her total amount of money that she has. And so that equation is just X plus Y equals 34,800. So then the second one is using this twice as much money in bonds as CDs. So I think I have to stop and think about. Twice as much money in bonds as CDs. So the bonds number is bigger. So what she's doing is she's multiplying the CD amount by 2 to get the amount in bonds. And so that is she's multiplying the amount in CDs to get the bonds. because 2 times 5 would get us 10. Let's say it was 10 over 5, whatever. So you're always like, I know it's tricky. So you have to think about twice as much money in bonds as CDs. So she's taking whatever she has in CDs, multiplying it by 2, and getting whatever she has in the bonds. Okay, so now we have our 2 equations. We can solve using systems of equations. I can use substitution. I can use elimination. I know those are coming back to you. So I'm going to use substitution here. I know if y is equal to 2x, I can substitute. Oh, there's my note. That's super creepy. I'm super sorry. I like write very close to the paper, and that was just appalling, and I'm sorry. Okay, so we're going to substitute in. X is going to stay the same. Instead of y, I'm going to put 2x equals 34,800. Combine my like terms. X plus 2x is 3x. Divide both sides by 3, and I get x is equal to 11,600. So we got our x. Now we just have to solve for y. Y, we just plug it in. So y is equal to 2 times 11,600. So that gets me, just going to plug that into my calculator, 23,200. So again, our question is in words, so we need to answer in words. X, remember, is the amount in CDs. So that means that Emma is going to put $11,600 in CDs, and she's going to put 23,200 in bonds. And that is my final answer. Now make sure it makes sense. Do these add up to her total amount? Is there a negative number? A negative number wouldn't make sense. That simply just doesn't make sense in a real world type of situation. Is this double? That, like we said, she wanted more money. She wanted twice as much money in bonds as CDs. She wanted more money in bonds. Is there more money in bonds? There is. So double check to make sure that these make sense. If they don't make sense, then go back and check your work. All of your answers should make some common sense here. Okay, we are going to do one more problem. We're not going to do it on the video. We are going to do it as a class. So if you're like, I don't know, in your notes, I'm going to have one more problem here, and that's going to be number 10, but we're going to do that in class. So if you need, I needed to have one more page. So if you need that too, make sure you have that. And we will go over that one in class together. So I hope you guys have a great day, and I will see you soon. Bye, guys.